Hello, everybody. Thanks for tuning in today. My name is Scott Ward. I am here to talk to you about AWS and Okta a year later. We're going to be focusing on some of the new and improved best practices that have come out when it comes to identity management and security for your AWS environments and how you best fold in Okta for that. A little bit about me to start with. I am a principal solutions architect with Amazon Web Services. I work on the partner team based out of Seattle, and I work with our security technology partners. So I'm working with their product and their engineering teams on the things that they're ultimately building for our customers to be able to use to help them with their security and identity goals while they're running on AWS. I've been in this role for about 6 years, and prior to that, I worked at Amazon as well. I actually worked in our internal financial systems team for 13 years, helping to scale, operationally support, customize that financial system for all the things that kind of went along with a very growing e-commerce company. Had a lot of different opportunities and experiences throughout my time at Amazon and AWS. So let's get started with why are we here today? So Okta and AWS are our partners. Okta is an advanced tier partner with AWS. They're in our security competency, and it's important that we are working together. We have a lot of mutual customers, customers that use Okta for what it's really good at, customers that are using AWS for the value prop that it delivers, and we want to continue to enhance that experience so that customers are able to use Okta and AWS together in the best ways possible. So we are working a lot with the Okta team. We've seen a lot of advancements come on both sides of the house in the last 18 months to help really improve that customer experience. And we're going to be continuing to work with Okta for a long time to be able to continue to deliver a lot of value for our mutual customers. So kind of taking a step back in the time machine, last year I spoke at the Oktane event, and I had a couple of key themes that I spoke to. So I talked about using the command line interface to federate into your AWS environment using the Okta assume role tool, and showed some examples of using that, helping people kind of who want to be more hands-on keyboard understand what they could be doing in that space. I spent a good amount of time talking about multi-account strategies, talking about some of the different architecture patterns that exist with or are emerging with AWS customers around using multiple AWS accounts and some of the use cases that drive them to use multiple accounts and really what that means from an IT perspective. And then we talked about automation around that multi-account setup, really helping customers understand how would they fold in my Okta environment to all these different AWS accounts and make sure that I can have my the strongest identity story as possible. So this year, we are going to focus on some different things, but they have some themes about enhancing what I talked about last year. So we're going to talk about integration with the AWS SSO product. We're going to focus more on the command line and really jump into some things that I think are very, very cool and pretty significant for Okta customers. And we're going to talk about attribute-based access and some of the advancements that have happened in that space to once again allow more of a tight coupling between Okta and the identity stored there and what's running and the permissions and access you give in the actual AWS account. So let's start with AWS Single Signon to kind of set the stage. It's a foundation for a lot of the other things we're going to talk about today. But before we get to that, let's talk about what it looked like. So AWS Single Signon made some pretty significant announcements back in December that we're going to talk about in a minute. But let's talk about prior to December. What did SAML integration with your AWS account and Okta look like? You would go in and you would define an identity provider in your AWS account. You would then go and as part of that identity provider definition, you would upload the certificate file from your Okta environment. You're then going to go through and define roles that in your AWS account that really reference that identity provider as a trusted entity, which then allows Okta to be able to federate somebody in to your AWS account using that particular role and the permissions tied to it. And then you're going to go through and whatever you're doing in your directory, associate roles and accounts with the users in that particular directory. And so these are things that had to happen for each and every one of your AWS accounts. And we'll talk a little bit more about where some of those challenges existed. But that's what the setup process was like prior to December 2019. So here's a visual representation of what that flow looked like. So you had the user signing into Okta, the single sign-on, choosing the AWS app. They would then have a SAML assertion sent to an AWS sign-in URL. If they were assigned multiple accounts or multiple roles, they'd be presenting with a really user screen to allow them to choose which accounts and which account and which role they wanted to be able to use. And then they would be federated with temporary credentials into that particular AWS account. So a pretty straightforward flow, and that's what it looked like. If we take that flow and kind of put a deeper lens on it, some of those setup things that I talked about, you need to create an identity provider in each and every one of the AWS accounts that you use. And you need to have the user permissions and roles defined in each and every one of those AWS accounts. And so the things that need to be done are pretty straightforward, but there's some challenges in actually being able to execute on those steps. And so some customers would take a manual approach. Maybe they're not using many AWS accounts. Maybe it's just one AWS account and that setup is really easy. Or they may even have multiple AWS accounts and they're choosing to operate at human scale, and they're just going to have somebody go into each account and do that setup. Some customers have explored more of an automation approach. I've actually helped with some proof of concepts and ways that we could automate some of this setup, where every time a new account is created, it's baselined through some scripts and through some cloud formation that would actually set up the identity provider and create the appropriate roles and permissions that are needed. So there's some ways to do that. They weren't super elegant. There are some advancements coming in AWS that might make that more elegant, but there were some challenges, and even some challenges existed for existing accounts. Sometimes there were accounts that existed in companies and they couldn't find the right owner, or they couldn't get the owner of the account to prioritize particular setups. So there was a risk that the identity integration strategy was a little bit scattered or fractured. So this is what things looked like as far as how you would take care of setting up your SAML integrations with Okta prior to 2019. So the AWS SSO service has been around for a couple of years. Back in, I think 2017 is when we first announced it. And at the time, SSO just supported logging into the AWS SSO portal and federating into your account or federating into some third-party apps. In December of 2019, at the reInvent conference, we announced functionality in AWS SSO where you can now add your own identity provider into the SSO product. So this is a really cool feature. It's going to add a lot of benefits for customers. And so what does that mean? Well, this flow here looks very similar to what I talked about a couple screens ago, but there's some pretty cool subtle differences here. So you still have the user signing in to Okta, having any MFA applied to that particular user, choosing the AWS SSO app and the SAML assertion of the AWS SSO product. We have a different kind of a chooser form where they're still going to choose which accounts and which roles, and they're ultimately federated into the AWS account with temporary credentials. The big difference here is that all of that other configuration I mentioned in the previous slides that was happening on the right is happening directly in the AWS SSO product. So you have your identity provider definition that you're going to make just once in AWS SSO. Regardless of how many accounts you have, you're just going to define Okta once. And all the user permissions and roles for each of those accounts are also centrally managed and maintained in the AWS SSO application. So no longer do you have to go in and provision and configure those in each of your accounts, or if you have changes or new roles to make, you no longer have to go in and get into every account and provision those in every AWS account. You're now doing that centrally from the AWS SSO product. So I think a really, really cool advancement. We've had a lot of customers who are very interested in this, and they think it's really going to help strengthen their identity story when it comes to AWS. And at the end of the day, the big focus here is really allowing our customers to have choice and be able to fold their particular identity providers in here, but still giving them a great place to be able to manage their AWS specific identities from one central location. So peel back just a little bit and talk more about like what's inside the SSO service. What are some of the things you're going to want to be aware of if you were to use this for integrating Okta? Well, first you're going to choose your identity source, and we've already talked about that. It's going to be Okta for the purposes of this presentation, but you can also choose the default AWS SSO directory or a managed AD directory. But Okta is certainly what we're going to be talking about today. And once you have your identity configured, you're going to go in and define the role-oriented permission set. So permission set, if you're familiar with identity and access management, there are a concept of roles which allow non-named users to get temporary access to your AWS resources. A permission set is very similar to a role, and actually when you create a permission set, it ultimately presents itself as a role inside the IAM product, so it will actually look as a role as well. For permission sets, what you do is when you go to create a new permission set, you are going to attach either curated, managed AWS IAM access policies to that permission set, or you're going to craft your own custom access policies and attach those into those permission sets. So now you have permission sets that are going to ultimately tie to policies that grant the permissions that a particular user is going to have in your AWS accounts. And then you're going to go through, and the final step on the right there is you're going to go into AWS SSO and you're going to assign either groups of users or individual users to specific AWS accounts, and then assign them specific permission sets. And so that's where all the access and where all the permissions for all of your identities is going to ultimately be maintained for your AWS environment. Now, building on that, certainly you could go through and you can create and manage all of your identities in AWS SSO manually. But one of the other cool announcements we made back in December was the ability for AWS SSO to support SCIM integration, the ability to actually sync your identity provider over to AWS SSO. And so our leadership announced that we are working with Okta to get the SCIM integration working, and I can still say that that is a true story. We are actively working with Okta to be able to get the SCIM integration between Okta and AWS working. You should expect to actually have that available to you in the next couple months. See it as an app that you can be able to get in the Okta integration app store and be able to start using. And so you would simply configure that app with AWS SSO SCIM endpoint that is specific to your SSO install, and provide the bearer token that is also generated by AWS SSO, and then you'll be able to sync all of your identities over to AWS, and that's going to allow you to then do that management where I talked about of creating the permission sets, adding the permission sets to the groups that you synced over with SCIM, and ultimately assigning them to the right AWS account. So going even further, just another thing that AWS SSO is doing to strengthen that story of being able to use a centralized identity source such as Okta, being able to manage your AWS specific identities and their permissions within one central spot, which is the AWS SSO product. So we talked about SSO and some of the value it gives, and how it has centralization, and it allows you to be able to kind of manage one or many AWS accounts and all the permissions from one specific place. So let's say that you've gotten all of your configuration done, you've got every account assigned the right users and the right permissions, and then you add a new AWS account. So what are some of the what happens when that comes to you? What are some of the steps you're going to have to go to? Well, minimally, what you're going to have to do is you're really just, for that new account, you're going to assign users or groups and the appropriate permissions to that new AWS account. So if this particular account has a purpose that ties in with all the existing groups and all the permission sets you have, you're just going to assign those to that new account, and you're off and running. Those users can now be able to federate in and use those particular permissions against that new account. Optionally, depending on the purpose of that account, you may have to define new permission sets. You may need to fold in different access policies for what that particular account allows or doesn't allow. You would need to assign those permission sets to new groups or to new users. You may need to create new groups in your Okta directory, depending on once again, on the purpose of that particular account, and then ultimately get the new permissions assigned to that new AWS account and to those node groups. So over time, you should expect to see that this will continue to improve as well, where you'll be able to automate more of this assignment and creation that I'm talking about here within the SSO product as you add new accounts or decide that you want to change permissions or groups within your AWS SSO environment. So what does this ultimately mean for you? I think the big thing here is the location to connect your identity provider. You're no longer having to go through and recreate the same identity provider definition in every single one of your AWS accounts, or having to battle to get access to an AWS account, or making sure that you're informed when there's an AWS account. It's all tied in and configured and defined the moment you do it the first time. It's a single place to be able to manage your identity permissions for your AWS account, so you don't have to, once again, go into each and every one of your AWS accounts to create roles and get those assigned to the appropriate identity provider. It's a central place to be able to create and manage and update those permissions. And it's a really strong statement from our side that you get to use the identity provider that you want. There's a reason you've chosen Okta. You want to be able to keep using them. We want you to be able to keep using that identity provider. We're just strengthening that integration story as it relates specifically to your AWS identities. All right. So let's talk about our friend, the command line. So I talked at the Oktane conference last year about the command line, and I think that what I have to show here and update everybody about is going to be really, really cool. Is going to really add a lot of benefit to a lot of customers who are using Okta and AWS. So when we talk to customers, or when I get feedback from Okta, there's some things that we hear from the customers as far as the command line goes. They really want to be hands-on keyboard. They don't want to be in the browser clicking around. They need to be able to go faster. So they want to be able to work from the command line. They want to be able to interact with their AWS environment from the command line, but they want to make sure that they're still following the right identity policies and processes, and that they're getting the right permissions. And so they want to still be able to federate into their AWS environment using their Okta credentials. They want to have that as the strong point of authorization. They want to be able to get the same temporary access as the browser offers. So they want to be able to have temporary permissions at the command line so that they can do their job, but also make sure that they're refreshing those credentials on a regular basis. They don't want to have to be able to create a named IAM user and long-lived access keys in the AWS environment and have those stored locally on somebody's desktop or out in the repository where they could become compromised or used inappropriately. And they want to be able to enforce MFA. They've defined all appropriate MFA rules and requirements when it comes to their environment. When somebody wants to do work against their AWS environment from the command line, they want to be able to make sure that they can still enforce those same MFA rules to ensure that the right people are getting the right access at any point in time. So you may be asking yourself, like, well, hasn't this already been solved? Isn't this something that's already done and I can move on and I can just start using it? So last year I talked about the AWS, the Okta provided AWS CLI Assume Role tool. It is a community tool that Okta's got out there and offered, but it's a best effort support. It's not a production product. It's not going to necessarily get prioritized for every particular issue you have or every question you have. And it's not feature parity with Okta through the browser. There's some things, you don't ever interact with a browser session to authenticate, and some of the MFA can't be enforced. And so there's a gap as far as the user experience and being able to ensure consistency around how you're authorizing people to use your particular AWS environment. Even from the Okta site, if you go to their help center, there's other attempts that have been out there to attempt to solve the CLI, really building a wrapper around the overall AWS CLI and trying to interact with Okta. You can see the Okta tool out here. There's some projects from Nike and half a dozen other projects where people have gone out and attempted to provide a solution that allows you to use Okta and the AWS command line So there's been lots of attempts out there to solve this, but customers have still come back and asked us, is there any sort of a way that AWS could offer some more of a native integration for identity providers from the command line? The open source projects are good and they're helpful, but they're still not giving them exactly what they need. They want something that is more strongly, directly supported and integrated with AWS, but still allows them to fully use their chosen identity providers. And so the answer I can give for that is yes. And so we have some really cool things that have come out in the last few months that allow us to be able to now give that answer to our customers. So the answer to that is really solved with the version 2 of the AWS command line interface. So back in December, the command line interface V2 was released in beta mode, and it became generally available on February 10th of 2020. And the CLI V2 has lots of improvements in general as far as how it works and it functions across whatever somebody would want to do for the CLI with AWS. But one of the really important things that CLI V2 delivered was its integration with the AWS SSO service. So now you can actually use the CLI to interact with SSO, and some of those flows that I showed you earlier where people are federating from Okta, getting a sample assertion and going into their AWS accounts are able to be replicated, but from the command line. So giving you that full feature parity of being able to get the same Okta experience for your authorization, but still be able to do the command line work that you want to be able to do with confidence. So what does that mean? You're going to be able to use the AWS service calls. You're going to be able to make them from the command line with the correct permissions. It's going to allow you to scale and have consistency around any automation and scripts that you want to do at runtime. We have customers who are taking a very big DevOps approach, and they want to be able to ensure that they can run commands consistently, that they can run the right scripts to be able to operationally troubleshoot their environment or deploy new features or be able to run updates against their AWS environments. And being at the command line and having the right permissions is super important to them. There's no long-lived credentials. You are being given temporary AWS credentials that are valid for a particular period of time based on the setup you've done in the SSO product, and you will need to refresh those on a regular basis. And so that means that there's less risk if credentials get compromised. There's less chance that there are long-lived credentials out there because you haven't had to create an IAM user and access keys for that user to be able to do your work at the command line. And it's giving you the ability to force MFA from your Okta environments. And so I think all of these are really exciting things for customers, and I think I've gotten some great feedback from customers who are really excited to play with this and think that this is a really big deal for them. So I think this is a very, very cool solution that you have available to you when it comes to the work you're doing on AWS. So what I'd like to do is take you on a little walkthrough of what that command line experience looks like so that you know what you're getting and how this really is going to work with your AWS environment and Okta. So the first step you're going to do when it comes to the command line and AWS and Okta is you're going to create your SSO profile. So you're going to install version 2 of the AWS CLI, and there's public documents out there on how to do that install for Windows, Linux, and Mac. The first thing you're going to do is actually configure the SSO product at the command line. So the AWS configure SSO command. The first thing it's going to do is it's going to ask you for the start URL for your SSO environment. So you're going to either go into the settings tab of your SSO environment or somebody do it for you, and they're going to grab the user portal URL. This is a unique URL that is specific to your SSO environment. It's not shared with anybody else. You're going to capture and copy that particular URL. You're then going to go paste that in to that prompt. It's going to ask you for the SSO region. You're going to put in whatever region your SSO environment was configured in. In this case, for my example, we're using US West 2. And then the command line is going to attempt to automatically open the authorization page for SSO in your default browser. So I'm going to walk you through what that flow looks like, and then we'll talk about what happens if that browser doesn't open or if you're in a browserless environment. So the flow that is going to happen is that your browser is going to open up, or it's going to open a new tab. The first thing you're going to see is a single sign-on verification. So at the line, you're actually given a verification code. I represented it with X's in my example. You're going to see this page show up in your browser. It's going to have the verification code already filled in for you. All you do is click on Next, and that is going to then redirect you to your Okta sign-in page. So you'll be able to sign in with your normal Okta username and password. From there, if you've got any sort of MFA configured, you'll be taken to the appropriate MFA prompts. In this case, I have the Okta Verify app configured for my account, and so I would need to go to my phone and collect the code and enter that code into this particular screen. And then at that point, I'm done. I've authenticated with Okta. I've signed in with my normal credentials. Given that I've responded to the MFA challenge, the next browser direct is going to be back to an AWS Single Sign-On page saying, well, I'm about to be signed onto the CLI. Are you sure? Am I sure I want to proceed? And by clicking on the Sign in to AWS CLI, it's going to give me one last screen that says I've been successfully signed in. At the CLI, I can actually now close that browser and go back to my happy place, which is at the command line and hands-on keyboard. Now, if I'm in a browserless environment, or for some reason my browser doesn't automatically open to this single sign-on page where the application code is filled in, you can still do all of these steps. And so on the command line, we actually give you the URL that you need to go to enter your code. So you could even do this on a mobile device. So you could be on your phone and actually go into that URL, plug in the verification code, and at that point, once the verification code's in, we will still redirect you to the appropriate Okta sign-in pages so that you can authenticate, do your MFA challenges, and then you will confirm that you want to sign in to the single sign-on, and you will be authenticated successfully, and the CLI will now work for you into the next steps that we talk about. So you have the ability to do this in multiple situations, the happy path being that we can open the browser for you, or if the browser can't be opened, you can still get through all of these steps and be able to sign in with your Okta environment successfully. So once I've gone through that lap and I've clicked on OK, and I acknowledge I want to create a CLI session, my CLI prompt is going to automatically switch to the next step, which is going to showing me all of the AWS accounts that are available to me. So in this particular example, I have 2 accounts that are configured for my particular user in the AWS SSO app. So it's going to list both of those accounts as far as the name of that I've assigned the account, the owner email address, and the account number. In this case, I'm going to actually choose the production account. So you can toggle up and down and through all the different list of accounts directly from the command line. And now that I've chosen the production account, the next thing the command line is going to do is show me all the roles that are available to me. So these are the permission sets that were assigned to me for that particular account. So in this case, I have a security audit or a view-only access. And so I'm going to actually choose the security audit. And then now I'm actually going through and doing some final just default configuration for the CLI. So if you've ever used the AWS CLI before, these are default configurations you would do for the CLI in general when you're installing it for the first time. So it's asking me for what's the default region that I want to operate in. I'm going to leave that at US West 2. It's asking me for the default output. So do I want JSON? Do I want text? Do I want a table format? I'm just going to leave that at just the normal default output. And then it's going to ask me, what do I want to name my profile? And so the default is just going to be the name of the role dash the account number, but you can name this profile whatever you want. This is something that should be meaningful to you so that you know how to reference it and you know how to easily remember it when you're actually running commands on the CLI. So you can name this whatever is most useful to you. At that point, the configuration of SSO for this particular profile is done, and I can actually start running command line stuff. That profile that you created is stored in a file. So when you install the AWS CLI, there's a hidden directory called .aws that has a file called config. That whole profile is stored directly there in the config file. And for every profile you create for SSO, each one of those profiles is stored here in this overall file. So if you ever forget what's the name of that profile, or which account is that particular profile for, or which role, you can always go back and refer to this config directory, this config file, and get that particular piece of information. So now let's talk about actually using that profile I've created. So if you go through and you do that configure and you create your profile, your temporary credentials are available to you right away, and you can start using command line. But let's assume I've created my profile, and I've now gone home for the weekend, and I'm back at my desk on Monday, and I want to be able to start doing more command line stuff. Well, the first thing I'm going to want to do is actually just log in. So the AWS login command with that particular profile name, it will go through the same flow as I walked you through a few minutes ago. If my session with the AWS SSO has timed out, it will open up that browser page to ask me to put in the verification code for CLI, ask me to go in and sign in to Okta, do my MFA verification, and then acknowledge that I want to go to the CLI and be done. If my session is still active with the SSO service, then I would just be shown this text, but I would be successfully logged in right away. And we can see it says it's successfully logged in here at the bottom. So it depends on the state of your current session. You can also do this SSO login for multiple profiles. So if you work in different environments and want to have multiple profiles active, you can actually do SSO login for one profile, go through the steps, and then you can actually do SSO login for a different profile. And those profiles will not be mixed. Temporary credentials for each profile will still be decoupled, and it will only be applied to the profile that you use, but you can actually have multiple profiles active at the same time if you want. And then at that point, I'm logged in. And so I can actually just use my SSO profile, and it's really just, at this point, me using the normal AWS CLI commands and referencing the profile that I created and have defined and then stored in that particular config file. So I can go through and with my particular profile, I can list S3 buckets, I can describe EC2 instances. These are really just standard AWS command line interface commands at this point. So it's really, really cool, and I'm really excited about this particular feature, because I think it's going to allow a lot of customers to be able to have the right controls in place, but still be able to do the things they want to do from a DevOps perspective and from an operations perspective from the command line, and still be able to use Okta and AWS the way they want to. So definitely recommend you take a look at this. This is all available today. I'll have some links at the end of this presentation for some documents you can go and take a look at as well. All right, so let's take a look at another cool thing that exists when it comes to identity providers and AWS, and that's about attribute-based access control. So this just a quick primer about attributes in general and AWS. So in our world, attributes are tags on your AWS resources. And so tags are nothing more than a key value pair that you define on the particular resource. Most resources allow you to have multiple tags so you can get the right information about there. And attributes have a couple of main purposes. In the beginning, that was actually for cost allocation. We were big advocates that you use tags to define key attributes on those resources, and then those tags would actually show up in the billing report that you receive from AWS every month, and you could actually go in and figure out, okay, what costs were associated with which resources or which teams, and you might actually be able to do some cost allocations around that. Attributes and the tags are actually very valuable for discovery. So there's some advancements in the AWS side where you can actually go in and search for resources that all have the same tag. So you could, find different resources that all have the same tag and almost kind of get a view of an overall particular environment or and now we're seeing a trend where attributes are actually being able to use for access control, where you can actually use permission policies to require that certain attributes exist on a particular AWS resource in order to be able to grant somebody access. So here's a couple examples of things that you might put on a particular resource as far as attributes and tags. every company and every customer has a different tagging strategy, and tags are super flexible so that you can do things that are important to you. So my advice would be, if you don't have a tagging strategy today, is that you come up with a tagging strategy, and that you really focus on defining what kinds of attributes and things that would be meaningful to you, and help to start educate and enforce that within your community, as far as people who would be creating resources and be required to actually associate these attributes with their resources. So we're going to be focusing on using those attributes and really what you can do when it comes to attribute-based access control, and using these attributes to really help with managing permissions within your organization, and ultimately helping you scale the access that you would have in your organization. Previously, customers would use kind of a resource-based approach, where they would have access policies in AWS, and they would list the list of resources that a particular policy could access. And that worked for a period of time, but as customers took advantage of AWS, the value prop it adds around being able to self-service and add more resources and being able to elastically scale, the number of resources would change. They would grow, it would shrink, depending on the period of time and the time of the day and the time of the month. And so it would require that those access policies needed to be maintained and updated with the new resources as they came and went in the environment. So it could lead to situations where your policies were out of date, either granting more access than they should or not granting enough access, and it required an extra emphasis on actually maintaining those policies as resources came and went. So attribute-based access control is really going to add a lot of benefits when it comes to being able to scale. So prior to about November of 2019, this is how customers would use attribute-based access control. They would have their employees in their corporate directory, Okta in this case, and they would have a role created for each one of the projects. So you see the 3 projects I have on the right that are really key value pairs, ultimately representing tags. They would have a role that would have in that role that the project key value pair needed to be for a project red, another policy for project green, and another policy for project blue. And then each user would be associated with the appropriate role. So that had helped to ensure that each user was only getting access to the resources that they wanted to, and that they should. But you run into some challenges here. One, you've got 3 different roles for 3 different projects. If you have another project come online, you have to create a new role. If one user needs to switch, you need to switch them to the different role. And if one user now needs access to multiple projects, they now need to be assigned multiple roles, or their existing policy needs to be adjusted. So there's some challenges around maintaining this and kind of doing it at scale. So what we announced back in November of 2019 was the ability for a feature we call session tags. And Okta was a launch partner for this particular feature. And what this allows you to do is that you can now use attributes that you have defined in your corporate directory and in your Okta directories in this case. And you can now actually send those attributes as part of the SAML assertion that you send to AWS. And then those attributes are part of the temporary session that the user has in AWS. And they are applied to the policies that you have defined in the role, granting them access to the appropriate resources. And what that means is that I have one role here, because I can be generic and just reference that the attributes that are passed in the SAML assertion need to match the attributes of the resource that the user attempts to access. And I'll show an example of what that policy looks like in a few minutes. But it gives you a lot of flexibility of being able to add more resources with more cost centers, add more users, use different attributes without having to modify and manage these roles, because you can really just use those as references to variables that are actually passed through in the SAML assertion. So let's take an example of somebody who's changing a cost center. Somebody who was working in cost center green has now been moved to cost center blue. And so you can actually, through this session tag functionality, you can update that attribute on the user in your directory and not have to make any other changes in your AWS environment. Now automatically only able to access cost center blue because you are now passing that attribute in the SAML assertion, and you have a role that is only allowing them to access resources based on the cost center that was passed in from the original SAML assertion. It also helps permissions for additional resources. So in this case, we have everybody set up with the appropriate access. Each project has a certain number of resources, but over time, we look to grow and expand on our environment. We're using more services. We're enhancing our services. And so as we bring more resources online, as long as they are having the same tags applied to them, these users will automatically be able to get access to those particular resources without having to make any changes to the roles or to your directory. So another great example of where you can scale with this particular functionality. At the end of this presentation, I've got a link to a blog post that Okta created that will tell you how you can actually go in and configure your Okta setup so that you can start passing in these session tags as part of your SAML assertions. So here's that policy I mentioned. So when you have a policy granting access, I've modified it so that only resources, I'm just looking for a tag of project, meaning that I just need to pass in the project in my SAML assertion. And this policy will enforce that the user can only access the AWS resources that have the tag of the project for the particular project name that was passed through in the SAML assertion. So different people working on different projects will all be able to use this same role as long as the project name is passed through in the SAML assertion. So it gives you the ability to really scale and be able to use a lot of different attributes to access your different resources. And then this is what the trust policy would look like for the particular SAML assertion and identity provider that you're creating. So you're going to have you're allowing a particular SAML advisor provider to be able to tag a session, and you're saying that these are the strings that they must send through. So if you have some particular strings or values that you always want passed through from your SAML assertion, you can say that they must pass in these particular ones for the SAML assertion to be successful. And here's what an interaction would look like in CloudTrail with somebody who is federating into your AWS environment through a SAML assertion from Okta. So you'll be able to clearly see the tags that were passed through as part of that session to be able to help further operationally troubleshoot or confirm that the right information is being passed through into your environment. So this feature around attribute-based access controls and session tags currently works for the pre-December 2019 way of authenticating into AWS through the SAML assertion. So we have to go in and set up an identity provider in each one of your AWS accounts. This works for that today. The AWS SSO team is working to implement this same functionality into the SSO product. You should expect to see that at some point in 2020 so that you can take advantage of this with the SSO product. So if this is something you're looking at, I would definitely recommend playing around with this now and understanding what your strategy would be. And then when SSO has this functionality, you can certainly adopt it within the SSO product. So here's some takeaway resources and some things that will be helpful and that you can take a look at further that kind of touch on the things that I covered in this presentation today. So stuff about SSO, about the CLI, attribute-based access control, the Okta blog about how you would set up Okta to be able to pass in attributes, and then a blog post that goes a little bit deeper into those fine-grained attribute-based permissions for your AWS environment. So we covered a lot today. We focused a lot on, in the last year, there's been some pretty significant advancements on the AWS side as far as the features and functionality that exist in the identity space, and they've been squarely focused on ensuring that you can bring your identity provider of choice with you and really allow you to use them. And I think this really helps strengthen the Okta story that our customers have and that you'll have when it comes to interacting with your AWS environment. So I really hope that these were helpful and useful to you today, and that they're going to really help you grow and advance what you do when it comes to how you use Okta and AWS. So thank you very much for your time, and I've really enjoyed presenting this information to you, and I hope you have a great day.